Hey guys, today we'll be talking about part 10 of problem 2.2 from the book Mechanics of Materials 6th edition by James M. Gear. Here, the question states that a uniform bar AB of weight W, which is equal to 25 Newton, is supported by two springs, as we can see here in the diagram. The spring on the left has stiffness K1, which is given as 300 Newton per meter, and natural length L1, which is given as 250 mm. The corresponding quantities for the spring on the right are K2, which is equal to 400 Newton meter, and L2, which is 200 mm. The distance between the spring L is 350 mm, which is this distance right here. And the spring on the right is suspended from a support that is distance H is equals to 80 mm below the point of support for the spring on the left. Hence the value of H, as we can see this, the difference between the length of the two springs is given as 80 mm. And now the question has asked us at what distance of X from the left hand spring should a load P, which is equal to 18 Newton, be placed in order to bring the bar to a horizontal position. Now let's look into the solution. Here, as we can see all the given data in the questions. Firstly, the location of the load P to bring bar to the horizontal position, we'll have to use the statistics to get the force in both the springs. So firstly, we'll put the summation of moment at A, which is equal to 0, and find out the equation for F2. Similarly, we'll put the summation of Fv as 0 to find out the equation for F1. And finally, we'll use the constant equation to define horizontal position, as we can see here. And finally, when we substitute the value of F1, which is equal to W by T2 plus Px by L, and put it in this equation, and also the value of F2, which is equal to W by 2 plus P in brackets 1 minus X by L, and substitute it in this equation, we will finally get the value of X, which is equals to 134.7 mm. Thank you very much.